Hello everyone, and welcome to the third webinar in the From Analog to Volume series. I'm Ryan, I'm based out of the Glasgow office, and this webinar is about how to extract grids from raster images. So this webinar follows on from the previous webinars that basically have been about building up a workflow for when you are wanting to extract data from a legacy dataset. So the first webinar by my colleague Jason was about how to display a raster image that's not georeferenced and how to then georeference that. And the second was by my colleague Belio, who used the raster tracker tool to extract fault data, contours, and polygons as well. In today's webinar, I'll be going over how to extract your depth grid or time grid, or really any type of bathymetry data really, from a raster image. So extracting grid data from raster images is useful for when you come across a map and you wish to have it as part of your dataset. Similarly, you may also have read a recent paper or report and you wish to add that to your dataset. Then you can just import the image as like a TIFF, GeoTIFF, PDF, PNG, JPEG, and then you can georeference it and start extracting the data. So first I'll begin by going through the theory of it, and I'll talk you through what each section of the process is before giving a demonstration at the end. So the whole concept behind extracting a grid is by building up a color gradient where each color represents a Z value, and this Z value can be associated with depth, through time, or an attribute. And the Z value is found by either a color bar or through contours. And on the left-hand image, you can see that we've built up a color gradient, and these colors are associated with the Z value, which is then used to produce the grid on the right. So to actually start the process of extraction, you must first select your raster image and then edit so as to bring up a spatial editor. And then when you're in the spatial editor, you would go to operations and create grid from raster. And this then brings up a dialog box that has different tabs that I'll go through. So the first tab is about image preparation. This is where you input files that you already have, so it's remove certain data. So the first thing you can do is include your tracked data, such as faults. And second thing you can also do is add in a bounding polygon, so as to remove all the noise outside your area of interest. So that would be like your legend, your color bar, things like that. And if there's something you don't want in the image, then you can also create polygons to blank out regions within the area of interest. So you can see from the image, this is your first image that's not had anything done to it. And then I've now added in my faults, bounding polygon, and I've also created some polygons within the image so as to remove some data as well here. So you can see though that they still have some noise to remove, and this can select the grid lines and the text. So you can remove that in the image pre-processing tab. So in this tab, you can add filters so as to remove any artifacts that you don't want. So the first one would be like a color filter. So if I wish to remove the tick grid lines or the fault symbols and the text, I would add a color filter so as to remove any black pixels, as you can see here. And you can also add a morphology, which will shrink or expand the foreground in relation to the background. You can also have a blur that can help remove artifacts and images that are pixelated. So for example, the writing there is quite sharp, so I might want to just apply a blur so as to make it a bit more smoother, and then it's not creating any artifacts. So to actually create a grid, we build up our color gradient, and we do this within the value extraction tab. So to actually create a grid, we build up our color gradient, and what we can do is we can use the color dropper to hover over either a pixel within a color pixel within the color bar, or we can also do it based on contours if we have them, to then choose the associated Z value. And once you've built up your color bar, once you've built up your color gradient, you can then toggle the view to either extracted values and unmatched values. So obviously extracted value is going to show you what colors you're picking up, and then the unmatched values are going to tell you which ones you're not picking up. And then if you're not picking up a specific color, then you can then add that to your color gradient. Once we're happy with everything, we now basically go to our output grid tab, and we can now name our output grid, choose our area of extent and our cell size. All right, now on to the demonstration. Okay, so for the demonstration, what we have here is a raster image that has some thickness data that's run to every time. And you can see here that there's no contours, so we can't just grid with contours, and we actually have to extract the data to create our grid here. So this is located just off the coast of Tasmania here, and the raster image that was brought in was initially not georeferenced, but my colleague Jason, so he georeferenced this, and I'll quickly show you the way you can georeference, and that's basically that you click on your layer, you'll go right click and then georeference image, and you then have this option to add control points. So if you're adding a control point, what you do is you'd basically click on the image, double click, and then you then map it to where it should be. Or you could also alternatively type in, if you know the coordinates of that specific point, where it should also be. What my colleague Abilio done, you can also track these faults here, as well as this polygon and some of these pipelines. The way you can track these data is to right click and bring up the spatial editor. Then you want to create a layer, and if you're wanting it to be saved, you'd obviously have it as a full definition there. And this allows you to then choose if you want fault, contour, polygon. I'll quickly do this. Then add faults, and then this week pencil comes up, and then you just enable your raster tracker, and it's going to here track any black pixels. So you can see here it's picked up a black pixel, so I now have a thumbnail, and it's just picked it up. So I can now drag it along and then go straight to the end and double click when I'm done. Okay. For this webinar, what I want to do is extract this grid data. So within the spatial editor here still, we will go to operations and create grid from raster. This has brought up our dialog box where you have your different tabs. And you can see here with the first tab, we have our source, and we're basically able to mask any data that we don't want in this tab. So if I had some polygons that have already been extracted using the raster tracker, such as what Abilio done, then I could add these here. And if I go to masked, you'll see that the faults that have been tracked are now gone. Since I'm only wanting to deal with this grid in here, I want to remove all of this, like your color bar and your legend and whatnot. So put in a bounding polygon. See that I'm now on the left with this data. Now with the image pre-processing, you can see that I still have some writing and some noise within my data that I might want to get rid of. So in this one, I'll add a color filter to remove all the black pixels, and I'll just increase this tolerance to about halfway, and it's going to now remove as soon as I click pre-processed. So you can see that's now being removed. What I've done here, I've applied a blur effect, and it basically makes it a bit easier just to extract the colors without having the interference of all these noise. Another filter I can add is the morphology. So I can erode, shrink the foreground just to make it a wee bit more. So now for what I want to do is actually extract this data point. So if I go back to my source image, you can see that we have our color bar down here. So I can now just add, choose the color pixel that relates to the Z value. So I can use the dropper here just to scroll over to the 0. And basically that Z value is 0. And then I can do the same for 1000. 2000, and so on. And what you can also do if you have a color bar that's basically similar, set up for gradient, and you have multiple different grids, then you can also save your color bar and load it for the next time that you're doing this. saved. You can use it whenever you wish. Just going to increase the tolerance here. So you can see from my extracted values, I've picked up these reds, purples, oranges, blues. And the ones I'm not picking up here are your more lighter colors, lighter greens, lighter yellows, lighter blues. So if I wanted to add these, I would just use my picker, choose which one I'm not really picking up, and then add C within here where it's matching. So I would say that's matching somewhere around the 1900 mark. Similarly, I could do the rest for all the other colors. I'm just going to move on from that, and I can now do the final one, which is your output grid. So I give this a name. So this is my thickness grid. So you can have your area of interest that you've set, and so your grid cell size. So just to make this go a wee bit quicker, I'm just going to increase my grid cell size to make it a wee bit coarser. And now you can create your grid. And so you can see here I've got my grid. My area of extent was, my area of interest, sorry, was a wee bit lower than the top. But you can see here if I toggle it on and off, it matches up pretty well. And you can see how quickly that was to do. Quite quick and powerful. So thanks everyone for listening. And just to remind you all that you can follow us on YouTube or LinkedIn for the latest videos and news by Petrosys. And if you ever have any questions or queries, please do get in touch. Thanks.